There are two rotational quantities that are best expressed as cross products that I'd like to talk about. The first one is torque. And torque can be written as r vector cross F. Remember that the r vector starts at the origin and goes to where the force is applied. Before we wrote this as rf sine phi, and again, phi was just the angle between r and f. So these two equations are completely equivalent. The difference is that now with the cross product, we can express torque as a vector itself, and it's going to be perpendicular to the plane that r and f are in. So that's really where this equation comes from. And again, this idea of a cross product here, if it doesn't make sense to you, you can just remember this equation and hopefully you can reason through which direction it's going to go. If I look at pulling down on this, and based on the orientation of the bar, I see that this is going to turn in a counterclockwise manner. If I take R and orient my fingers with R and then bend them towards F, I see that my thumb is pointing out at me, and that's what this vector shows. Another quantity is angular momentum, which we're going to talk about in the next video. This can be written as r cross p, where p is the momentum. Now this is actually only true for a point particle, and we are going to look at some different ways of expressing angular momentum. But in this case, the idea being that you have the momentum of some particle and the radius to where it is. Now note, one thing to be careful of is that we don't actually say that the particle is at the origin in this case, but the particle would be at the the tip of r, and it would be, for instance, going this way. And so when you have that, you say r cross p, and again, if you can do the right-hand rule on this, initially your hands are pointing away from the screen, you bend it slightly towards the screen, towards P, and your thumb points up in that case. Now how we write this then is that P becomes mass times velocity, or in this case, speed, and so it's mRv sine beta, where beta is the angle between those. So these are two quantities that are really well expressed as cross products, but if you can just work with this simplified equation if the cross product doesn't make sense.